Hello everyone, my love relationship with AIO coolers is officially over. My ID cooling here doesn't want to work nice anymore, so I get crazy high temperatures even in idle, and when I'm doing something with the computer, even if it's a very light task that only uses one core, one thread or something like that, is going to go to 80-85 degrees, or if you do something a bit more complicated, it's going to thermal throttle at 90 degrees right away. And you can see here there is practically no CPU activity, and I already have more than 60 degrees centigrade. You can see the pump is running at full speed, no slope, and is doing over 2000 RPM. So I'm going to start the mem test. Only one thread, one mem test only, and you can see that this CPU temperature has already spiked to almost 80 degrees centigrade. And there's no other activity, so this is just a light load. You can see the CPU is not even clocking to the maximum speed, and it has went over 80 degrees centigrade for a moment, so not great at all. So just to use it for now until my replacement cooler got here, I had to use the BIOS option to force it to work in eco mode, which drastically reduces the TDP of the CPU, the power, and I'm actually working at limited power. So because I'm using a small chassis and I do not want to change that, because I have a really nice looking older case, it's a Thermaltake Gullwing model that has a rounded top and side cover from one single piece of plastic, and I really like it because it's small and I don't want a larger case. I want to keep this, but the problem is with air coolers that most of them do not fit, and the idea was that when I upgraded my CPU, I went with the AIO just to have more cooling capability. By the way, you can see the installment of this system. I'm going to leave here probably a link for it. You can check that. So recently found this Noctua, which is not so new on the market, but it's a low height, low profile CPU cooler. And in theory, Noctua says that this should cool the Ryzen 5900X model that I have here without any kind of problem. So I'm going to take out my improvisation here, and if you are looking at this thing here with the bracket, this is specially mounted on top of the AIO to actually cool the surrounding of the motherboard, because my motherboard has 6 or 7 years, and with the latest BIOS updates, this can run from a Ryzen 1 series CPU. It runs with the latest Ryzen 9 series, so it's a huge bump in performance, and I doubt that this motherboard was designed to be able to supply so much amps to the CPU, and I went with some adding of MOSFETs cooler here, heatsinks, and even so this area was getting very hot, so added this improvement. And before you start installing the Noctua cooler, be sure that you still have the original backplate, in case if you had another cooler like I have this AIO, it came with its own backplate, and it's probably not going to work with the new cooler, so be sure that you have the old backplate. And now let's take the parts out so we can remove the motherboard. We need to get a video card out, and I have another PCI Express SID, SSD drive, and another gigabit Ethernet adapter, so I have to take all of those out first. Power cable of the graphics card, and now it has here a clip that is not in a very good position. Alright, and I also need to disconnect the wires from the coolers. It's lucky that I have 4 hands available. And now let's move further. So I'm going to take the power cable from the motherboard, and I have here the USB cable and another one here. This is one for the RGB or front fans here, another USB, and the power button, and the other main power cable. So that's off, and now we can take the screws out for the motherboard. And I'm also going to remove the AIO pump from the CPU, and later I'm going to remove also fans and radiator there. And the pump wire. And goodbye pump, you are no longer needed, and probably I'm never going to use an AIO or pump ever again.
The cat is here.
And the motherboard should come out now. Yes, it's out. And we can now remove the old backplate and put the new one and install the provided spacers from Noctua. Okay, so let's open the Noctua box and see the installation kit for my motherboard. Alright, and this is the heatsink with pre-installed fan. Okay, I'm going to leave it here for later. And we are opening now the kit box, the installation accessories. And we have a small manual here, we have some brackets, and we have here parts label. This is Intel parts, AMD parts. And we have here these plates and some other brackets. And we get some thermal paste, extra clips for another optional fan, thermal paste, and cable adapter, and this tool to help us install things. And of course a Noctua metal sticker. Alright, so to install these parts first, we need to take the old backplate off. This is easy to be done just by hand. There are also some washers here. I'm going to save them for later. You never know what AIO I'm never going to install back, but I'm keeping them for later. Alright, and now the original backplate goes under the motherboard. just like that. Now comes a very interesting part and very important. You have these plates, and these plates have a 0 position and an offset position, both of them. Also, they are labeled with south and north and a CPU direction. So south is up on the motherboard, north is down. And when you are installing this, you need to find the correct position for your socket. They give you some instructions here. It says that for some models with M4 it's better to use the offset, while on other it's better to use the no offset option. The idea is that you want to get as good as centered position of these two screws between your processor, so they should be at equal distance. Also, the plates should clear if you have any kind of circuits on the board. So I can use here on this part, I can use both the offset and the 0 position, while on this part here it's the same, I can use either of the positions. So it's up to me to choose if I want offset or not, but the idea is that you use offset on one side, you need to use offset on the other part, otherwise you are not going to have the desired length between these two screws, so you are not going to be able to clamp this on your CPU. But before you decide with the clamps, also keep in mind that you need to put these plastic bushings, and I have decided that I'm going to go with the non-offset position because it's somehow centered in my case, and I'm going to put the screws now to hold it in place that way. Also, don't overdo that. It's especially written in the manual that don't overdo it. Just tighten them a bit, and that's all. Also, don't forget to clean the CPU while you have the occasion now. All thermal paste must go. And now we can install the motherboard back, because we are not going to put the cooler right now. The cooler is going to be installed after that. It has this clamp here with the spring-loaded screws. I'm going to take out the fan from here and use the provided tool. That's why it's so long, so you can actually reach those screws and lock them into place. The cooler will go something like this, and it fits nicely. It clears the RAM modules just fine. I'm going to try to show it something like this, so no problem there. It's not hitting anything. It's going to have good airflow, because even my tall RAM will not block the airflow, but I will not be able to install a front fan probably because of that. I'm going to check that later. And the radiator is now also off, and we have much more space. We are going to probably install later some front fans, but now we are going to install the motherboard back. Now we are going to add the thermal paste, and I'm going to use the 5-dot method, one in the middle, a bit larger, and another 4 ones near the corners, actually from the distance, equal distance from the center to the corners. And now I'm going to put the heatsink. Don't forget to take out the plastic protection. So this goes in like this. And now with the provided tool, we are going to start to fix this gently from both parts. And now I'm going to clamp the fan back into position. And don't forget to connect the fan to the CPU header. And now all I have to do is to install the graphics card and the other boards back and test it out and see if it still works or not. Okay, so the test is now again starting with the Noctua fan and cooler installed. So I have the same configuration here with minimum activity here, only background apps that are working. And you can see that the idle temperature is not impressive at all, but I also have here a rather silent and flat slope for the fan, so it's doing around 1000 RPM. It's basically super quiet right now, so you cannot hear it in comparison with my AIO, which was using three fans that were rather noisy, and I also had an extra case fan. So all of that is out. I haven't installed even a system fan right now, so it's only the CPU cooler inside. It's not making much of a noise, actually not at all. And you can see here that the temperature is rather high. But let's put it to the test, so I have confidence that this is going to somehow work better. So I'm going to start the mem test again. So the first test is running, and you should see here that a core, actually a thread, should spike and go to full. And the temperature has risen a bit. I'm going to start another one, and another one, and another one, and another one. And look at this. Actually, the CPU temperature is getting down right now, and it's just fluctuating a bit, but it's no longer going to 80 degrees, which was huge. And actually, I don't have any case fan installed, so all the heat is inside the case right now. It's not going out. It's nothing that it's pumping it outside. So this should work a lot more better if I install at least one or two fans to vent the air inside the case. But I find this amazing, and it's no longer getting crazy temperatures without doing anything or just running a single thread. So you can see here that the CPUs here, actually the threads, some of them are maxed out, and I have no issues no more. You can see that the CPU clock is boosting for some cores, and I'm almost at the maximum frequency. The CPU is by default overvolting like crazy, but I'm still in echo mode because I could not use this CPU without activating echo mode. And I'm going to stop the test and try it again with echo mode disabled and see what happens. So I have restarted, disabled the echo mode. You can see now it's default, no curve optimizer, and the idle temperature is fluctuating, and now it's lower than it was before. This CPU has huge temperature fluctuations, but as you can see, it's rather cool. The fan is again slow. I have minimum activity here, so let's start testing it again. Oh, I'm starting multiple tests. 2, 3, mem test, fourth one started, and fifth one. And you can see that the CPU has gone up a few degrees, 66, 65, but it's no longer going to 80. And you can see the curve here. If I increase the fan speed, something like 60%, it's probably going to get even more better. But keep in mind, I do not have any kind of other fans installed right now. So it's just the CPU cooler. And you can see that it's keeping it even under 60 degrees with those spikes, but it's no longer overheating. Okay, and here's another test. So it's the Horizon Zero Dawn. This game has never worked for me without actually activating eco mode because it's going to go up to 90 degrees here and thermal throttle, and it will work very bad. So now I'm no longer in eco mode. You can see that the power here it's already at 100 and something watts. So I'm on full HD monitor, graphics is ultimate quality. So let's start the benchmark and see how this goes. And if it's going to thermal throttle or get close to 80, 90 degrees centigrade. And right from the start, we can see that it's doing 67 degrees, not that much. Actually, now the GPU is hotter than the CPU, which is interesting. And I no longer having thermal throttle, which is amazing. It's just that it's something that I wanted, actually. And it's interesting that an AIO, it's so bad these days, and I will never, never, ever use another one, regardless of the brand and the quality, even if it has 6 years warranty. It's just a headache. Uh, why not use a simple air cooler? This actually keeps my CPU cooler. I can actually overclock this right now, but I don't need to do that. I just want to have a cool CPU that works nicely and doesn't thermal throttle. So no more water cooling for me. This is the way, as someone says. And here are also the results, which are actually decent for a full HD run. I consider them to be okay for my style of gaming. But the most important thing is that I have solved the problem with the CPU overheating. And as simple as that, that's how I downgraded and upgraded my cooling of my CPU from having air going to water and from water going back to air in the last years. And I could not be happier with air cooling nowadays than with faulty AIOs that only give you trouble. So that was it for now. Be sure to follow my other videos, and until then, see you and bye bye.